little bit more of that. Since it's just Jeff, hi Jeff, you're muted. I think we have at least one other person who just called me asking for the meeting information, so because they couldn't get in from wherever they were. So hopefully we'll have a couple more. But anyway, I'd like to welcome you all to this experimental and highly informal AITP board, or excuse me, general meeting. We'll come back to that, whatever it is. We would like to welcome you back. You know, we're trying something new here to try to get around the impositions of the COVID panicdemic, as people call it, and we'll be talking tonight about change control and version management using Git. Our presenter is, as you probably know, Mr. Don Pezet. I've known him for a lot of years, and he always seems to have almost expert knowledge in any topic I've ever come across, which is just flabbergasting and amazing and impressive. So I hope you'll appreciate the work he's done into this presentation. And with that, I'm going to go ahead and turn it over to him. Don?
All right, thank you, Michael, and we'll go ahead and get started. Michael did a great introduction for me there. So I am Don Pezet. I do happen to be the president of the North Central Florida chapter of AITP, but I like opportunities like this where I kind of set that title aside and get to be the presenter in my day job. I am the co-founder of ITProTV, which is a training company. We create various computer training videos and stream them on the internet. We have a number of developers and engineers on staff, and we use the heck out of Git. Now, I want to start this presentation by saying that I am not a developer. That's not what I do. It's not what I've ever done. I've been a network engineer, a sysadmin, a trainer, but I've never been a developer. And for a lot of people who are very similar to me, they might not understand why Git is important or how we can use it or how it pertains to people other than developers. So that's one of the things I want to help shed some light on tonight and show you guys ways that you can make use of that to handle change control. Now, change control is something that falls a little more near and dear to my heart because I have been, of all the titles I listed earlier, the one title that's stretched across all of my various careers is a project manager. I have handled projects for a number of different companies, small and large, and in projects, you learn that change is the enemy of success sometimes. Sometimes change can be the secret that helps you win the battle. Sometimes it can cause a lot of problems. We want to make sure that change is always implemented in a proper, consistent manner so that our projects, and even not our projects, just our regular day-to-day operations go successful and we don't introduce risk into our business. So that's where I want to start, is change control. That terminology gets bandied about quite a bit, and a lot of people don't have a great grasp on exactly what we mean when we say change control. Change can be a big thing, like when you move houses, right? If you move into a new school district and your kids have to go to a new school, that's a big change. But change can be a little thing, like changing the locks on your house. And in the IT world, it doesn't matter if it's a big change or a little change. Even little changes can change the attack surface of your network and lead to a data breach, can lead to downtime, can lead to inaccurate documentation that hinders your ability to troubleshoot a network. It can cause all sorts of problems. So change isn't bad. It's just we need to be aware of it. We need to document it. We need to have records and be, just consistent in how it's applied. And I'll give you a story. I used to work for an insurance company, and one of my coworkers was a brilliant man who really, he knew a ton of information about every aspect of that environment, all the servers, all the network. And he had an amazing work ethic. He just did a ton of work. But you could always tell when he was about to go on vacation because he would work twice as hard. He was a workaholic, right? So if he was going to be out for a week, the week prior, he would do 2 weeks worth of work in that 1 week. I mean, he would just work and work. And then he'd go on vacation. And I always dreaded those times because I knew I would come in Monday morning and something would go wrong. And then I would have to reverse engineer. What what happened last week? Like what all was changed? And I have to go and dig through and try and figure out what happened to get the system back up and operational, or sort out whatever little problem it was that we had. Now, if you're implementing proper change management, that's not such a hard thing. You've got a record of every change that was made. And so you just pull up a list. Hey, show me everything that changed on Friday. Show me everything that changed on Thursday, on Wednesday. And then you undo those changes until the problem goes away. Problem solved, right? You don't even have to be a rocket scientist to do that. I think back to my old, the early days of my career when I was doing desktop support. And somebody would say, Microsoft Word isn't launching on my computer anymore. Okay, well, has anything changed on your computer recently? And what do they always say? Nope, nothing's changed. But then you start looking and you say, all right, what's this weird macro plugin thing? I don't recognize this. And they say, oh yeah, I installed that this morning. Well, wait a minute, you told me nothing changed, but you just installed this other software this morning. So we can't necessarily rely on our end users to keep us informed of their changes. How do we expect our IT staff to do that? And the short answer to that is professionalism, right? If you're working in IT, if that's your career, you should be professional enough to document the changes that you make. But even if you work in a non-professional environment, you can use systems like Git to force people to document the change. That the documentation actually becomes what implements the change, that the change can't occur without the documentation first. And that helps to create that environment where we know exactly what is going on in our system. Now, when we talk about systems like Git, people always think programming. They think about, all right, I'm writing an application or a PHP web app or JavaScript, Node.js, something like that, and I want to track all the change. And Git will do that excellently, right? But you can use Git to track just about anything. I've used it for Cisco router configurations and Cisco firewall configurations. I've used it for Terraform definitions for doing bulk deployments. I've used it in combination with systems like, various automation systems like Puppet and Chef. It's phenomenal for keeping track of the changes in those playbooks. And you don't have to be a developer to use those. Those are really just scripting languages, right? And so you can track all the changes that happen there and redeploy based on them. Really, really useful stuff. But the biggest advantage of Git is that it's free. It doesn't cost anything. And so when you're tracking network device configurations or you're tracking programming applications, it's a pretty easy thing to implement. So there are a few other terms that get confused with change control. So I want to highlight those real quick. You'll hear people talk about configuration management. Configuration management is different than change control. Change control, change can apply to anything in your environment. So ongoing operations, functional applications, line of business applications, it can apply to anything. But when we talk about configuration management, that's managing the changes on a particular product, one application, one project. That project has a configuration. Maybe it's a web app where you have a web server with an application server behind it and a database server behind it. Those three machines working in tandem provide that web application, and they have a configuration. And configuration management is tracking the configuration of that particular web app versus change, which is a more generic term. Change control applies throughout your entire system. There's also version control. Version control is something that you will hear programmers use and really only applies to programmers. When a programmer sets out to, or I say programmer, developer, engineer, right? We have a lot of different titles that fall in that scope. When they have an application, you've probably seen version numbers, right? This is version 1, version 1.1, 1.2, 1.5. Well, how do they decide what features and bug fixes go into version 1.2 versus 1.3? Well, they come up with a requirements list. Here's the requirements I need to meet what I want to be in the 1.2 release. And then here's the things I'm not going to get to in 1.2 that I'm going to push to 1.3 or 1.4, right? We can't fix everything all in one fell swoop. We've got to take our time and move piecemeal. And so they need version control to say, look, we've decided to fix these 20 showstopper bugs before we release 1.2. If we want anything else, it's going to have to go in 1.3. And by doing that, it protects them from taking on more work than they can get done in a reasonable period. We've probably all seen software projects that get pushed back, delayed over and over again. You see it in the video game industry all the time. You know, this game is promised to come out in August, and then it gets delayed to March. And then it's the next August and the next March, and it just keeps going on and on and on. And it's because they keep adding new features. Those new features create new bugs. Those new bugs have to be fixed, and then the cycle repeats itself. So version control is designed to stop that. And that really is a programming technology. So I'm going to focus more on the world of change, and really thinking about it in terms of a project manager. The way we managed change in the past was with change documentation. Let me share my screen real quick and I'll show you an example of what I mean. So I'm going to share my desktop, and I'm not the best at this stuff. So let's see how we do here. All right, so what you guys should see is a Word document open up on my screen, which is a change request. All right, so this is a document that I've used at a couple of different companies or variations of it, that when somebody wants to make a modification, let's say Wes is working on the network and a firewall is not behaving properly, and he identifies, oh, this is a Cisco firewall, it's got a bug, Cisco released a new version of the operating system for that firewall, so I want to upgrade it to the new operating system. All right, that's a change. He might not be changing the configuration of the firewall, but he is changing the operating system that's on it. That's a change. It's going to have a different ASA operating system or whatever they call it. So he would then go and grab this form and fill it out. All right, what's the change title? So this is going to be update firewall firmware. Or something of that nature, right? The functional manager, who's in charge of this employee that's going to be submitting it. So, you know, Wes may work for a network manager. We'll say that's Ronnie Wong or whoever, right? So this is where the authority is going to come from. But the requester at the end of the day is Wes Bryan, right? He is the one who wants this change to happen. He would fill out the date, and if we had a change number, we would assign that. That's important to be able to reference these and come back to them in the future. And then he would designate the category. You know, maybe this is a network change, and so he would designate it here. Maybe it impacts other things. Maybe this is an emergency change. There is a compromise on this firewall that's got to be fixed right away. So he would designate those values. And then he would start the arduous part that everyone hates, which is filling out the rest of the information. What is the proposed change? Well, he's going to replace the firmware. It's an old firmware version. He's going to replace it with a new firmware version. All right, but we need to be a little more detailed than that. What does that involve? Well, he's got to make sure it has enough free space to store a copy of the new OS. He's got to copy it up there using SFTP or SCP or something like that. He's got to change it so it knows to boot from the new version, and he's got to reboot the firewall, which is going to cause a minor outage, and then it's going to boot up, and the problem will be solved. All right. What's his justification for it? Well, his justification might be that there's a security exploit on that firmware, and so we need to roll this out, otherwise we're going to get hacked. That's a pretty good justification. But it might be something a little softer, like, well, I like this version of the software better because it supports some kind of shortcut system. That's a realistic request. It's not out of the ordinary for somebody to want something to be a little bit easier to use, but it's a little harder to justify downtime that way. Then the impact of the change. The impact of the change should be positive. We're going to be more secure. People won't be able to hack into my network. But it's also going to create some downtime, right? There'll be downtime while the network reboots, and so that's an impact. Who is it going to impact? Depends on who's behind the firewall. We need to document that here so we have a good idea of what this change is going to cause. And then my favorite one, the rollback details. If things get screwed up, how do we undo it? How do we put it back to the way it was before? And so those are really important because the person who has to do the rollback might not be the same person who did the change. If the change is bad enough, Wes might already be fired. And so we need someone else to come and do that rollback, right? And then any other comments that we have, we'd fill out there, right? This form would then get submitted to a change advisory board or whatever terminology. Some people call it a change control board, a CCB, a CAB, CAB, whatever terminology it is you have for it. But it gets submitted to them. And those are the people who are going to either approve, defer, or decline the change. If they approve it, we move forward. If they defer it, that means we need more information. And that's what would go here in the justification field. or if we decline it. You're not going to make this change. Here's why, and that's that. And then we sign off on it to give it the authority to allow that to occur. Your change document may have more information in it. It may have like proposed date and time of the change or maintenance window, other various things. There could be a lot more in here, but this is kind of a boilerplate what a change ticket might look like, right? The problem with this solution is it's 100% dependent on Wes filling it out and submitting it, and not just Wes saying, whatever, I'll just update the firmware. You know, if he's a network admin, he probably has the authority to go and do that. He'll just update the firmware and that's it. And that's true of change anywhere in your IT department, that you've got administrators, you have people who have authority on the network, authority in the Active Directory, authority in the application code repositories, whatever. They could make change on their own. And a system like what I just showed you, this is the old way, doesn't protect you from any of that, right? People can just make unauthorized change. And that's where Git comes in, that its purpose is to take all the stuff that this form does and effectively make it mandatory. Maybe not mandatory to fill in all this information, but at least mandatory to get approval before the change can roll in. And so that's what makes it really, really powerful. It helps us to prevent unauthorized change, and it helps us to keep track of the authorized change, the stuff that we wanted to have. We're able to keep track of that so that if something goes wrong, we can roll it back, put the system back to the way we wanted, and get things operational and going again. All right, now, if you've never heard of Git before, it's pretty unlikely because it's become ubiquitous throughout IT environments around the world, but maybe you're just getting into the field, so it's new to you. Git is a software package that was developed by a gentleman you might have heard of named Linus Torvalds. He is most famous for being the creator of the Linux kernel that powers the Linux operating system we run today. So pretty famous guy, and deals with one of the largest open source projects in the world, if not the largest. The Linux kernel is not necessarily a big program, but it is so super important to the entire functioning of the internet. It's mission critical. And he works on it with a team of like 20 senior developers and then thousands of open source contributors. That's a lot of people working on the kernel. He's probably got to keep track of some change, and he certainly needs to approve it or decline it. And if you followed him, you know that when he declines things, he's usually pretty colorful about it. He does not hesitate to make fun of people's intelligence when he rejects a change, which also is a funny thing about how Git got its name. It is not an acronym. It doesn't stand for something. And when asked about it, Linus Torvalds said, well, you know, based on Linux, I typically name programs after myself. And so that's why he named it Git. And so it's a derogatory term in the UK, maybe not something as funny here in the US, but it's entertaining. So, so he created it because there wasn't a good code management platform available at the time. There were other things like CVS and Subversion and things that just didn't work well for what he wanted. He wanted something that was flexible, that was distributed, that was lightweight, and those other solutions didn't meet any of those categories. So, so basically, he and a group of other developers got together and created Git, which has become wildly popular. Now, I do want to differentiate Git from GitHub. A lot of people use those two interchangeably. Linus Torvalds and an open source team created Git. It's absolutely free. It's completely open source and anyone can use it. And it does not depend on cloud services whatsoever. You don't even need an internet connection to use Git in your internal environment, right? GitHub is a third-party commercial product that is owned by Microsoft that is not related to Linus Torvalds in any way. And while they do have free packages, it's not open source. It is a cloud solution, right? Now, if Git is free and open source, why would I pay somebody else to help me support it? And the reason there is that GitHub actually adds some extra functionality to Git that's pretty important. Git by itself allows me to track changes and be able to exchange information between other people that are working on the same repository. But Git is missing a few important things. First off, it does not have authentication or permissions whatsoever. So Git by default works on trust. Trust that people are not messing around in other repositories and skipping files and things like that. You can enforce authorization by using like file system permissions and other things, but it becomes difficult really fast, right? So it doesn't have an authentication piece. The second thing it doesn't have is a workflow for approving or denying changes. And so if somebody submits a change, there's no notification to the maintainer of that repository that they need to pull that change in. They don't see that. So we have to have some other way, email them, call them on the phone and say, hey, can you merge that change in? And then they go and they do the merge. But as it stands, Git doesn't do that. So Git is somewhat limited by itself, but GitHub lets you use the Git tools on your own machine and then submit your changes up to a centralized repository in GitHub. And there they add authentication. They add a workflow for approving or declining changes where you can provide additional information and you can have a full record of all the changes that occurred in a nice little web page that you can navigate through. So they create a huge amount of value. GitHub is an extremely valuable service. It's not the only one that's out there though. There's also GitLab, which is another very popular one that is not owned by Microsoft. So people who aren't big fans of Microsoft can use a solution like that. Many of them will offer a lot of features for free, and then there's just like one or two pieces that will actually cost a little bit extra. But basically, that's the main gist of it, is that web services like GitHub really add a lot of value to what Git can do. So I'm going to use GitHub and Git. I'm going to use both the command line tools and the web tool here in my demonstration in just a few minutes. All right. But the key thing is that with GitHub, we can do approvals, we can do permissions, we can roll back changes, and you can do all that via a simple web UI. And there's a ton of third-party clients that you can use to be able to connect up to GitHub, to be able to use a GUI. So it doesn't have to be a nightmare to leverage that stuff, right? Okay, so I have been jabbering on about what Git is for quite some time now. Let's actually see some of this stuff in action, okay? I'm gonna share my desktop again, and let me bring that up. There we go. And I'm going to get out of this lame change ticket. And I'm going to jump over here to a little project that I made. So I made a project called AITP demo. I made it about 2 weeks ago. And I dumped some files in it. And so when you look at it right here, I can see that this is the Don Pezet / AITP demo. That's a repository that I made. And a handful of files got dumped into it. And you can see the last time those files were modified. Most of them 13 days ago, that's when I put them in there, right? But some of them have changed since they were initially put in, okay? In fact, it looks like all of them have changed since they were initially put in. So with each of them, you can see little notes over here. Index.html, heartbeat.php, see how they say populated repository and there's no number after them? They have not changed since I initially put them in. But these other ones, there's code sanity, number 1, new router configuration, number 3, remove redundant and default lines from the config file, number 2. Those are changes that occurred. And so it's detailing the last change that happened to that file. And what's really cool is if I want to find out what happened, like what exactly changed? It says code sanity. What the heck does that even mean, right? So let me go in and find out what it is that changed here. I can click on that number 1 or click on code sanity, and it's going to take me to that change. And I can see that Chris Walken added 2 commits to it. And it looks like he did something. He corrected a file name to lowercase. All right, so there must have been a file name that was in uppercase or whatever, and he changed it. That can be, that can lead to a cascading failure because like in Linux, files are case sensitive. He's changing cases that could break things. And so I can click on one of those to find out what exactly he did. And so when I look at it here, I can see in the CSS file, in the cascading style sheet, he changed the background image. And see what's red here? The red is telling me something that's gone. And the green is telling me something that's new. He changed this line to make the M in moon that was capital lowercase. All right, so he must have changed a file name also, but I don't see that here. But right up here, I can see a binary file changed. A text file, it can show me exactly what changed, but a binary is a little bit harder. And so if I were to click on that, say I don't get any information on it, I could copy it. But otherwise, I don't actually see what changed based on that because it is a binary. But we see a lot more information on the text file all the way down to exactly what changed right there. And if I go back, let me back up a little bit here. I think I clicked on the second one. Let me click on the first one. And when I click on that, here's the binary. And again, it's telling me binary file not shown. But I can see right here that the M in moon is lowercase. That's what was changed. And those changes were submitted and rolled into the project. So if I go back to my code screen here, I can find moon has a lowercase m. And if I take a look at the style sheet, the full style sheet right here, that m is lowercase as well. So that historical view of being able to look at things is kind of laid out right here in an easy to see manner, all right? Now, I mentioned that GitHub can basically enforce change control, right? Chris Walken came in and made some changes to my application here. How did he do that? Did he have permission to do that? Well, the answer is no. He made a change and suggested it to me through what's called a pull request. The pull request is effectively a change request. He said, here's a change that I want to make. Will you approve it? And then I had to come in and approve that change. Now, looking at it here, I see there aren't currently any open pull requests, but I'm going to go to closed. And I should see, here we go, here's 3 closed pull requests. These are ones that I grabbed and merged in. So I had the authority to bring those in, and that allowed the project to be changed. So that's that enforcement I was talking about. Let's see what that actually looks like in practice, because in practice there's a little bit more to it. On my project, this AITP demo, see how it says master right here? So this is the master, or the think of it as like the master copy of a record. Like well, records are a bad example because not everybody has those anymore. So this is the original or the key source of my application. But if I drop that down, I might have branches. And these branches are where somebody went in and modified something. A branch is nice because they can split it off, have their own copy, make whatever changes they want, and it doesn't mess with the master. But then they could submit that as a change and I can bring it in. So anybody can come along and create a branch and then make some changes, but that doesn't change the actual project. There is another thing called a fork, and a fork is different. A fork is where you completely clone the project. And now you have your own copy of the project that you can do whatever you want with. That doesn't affect the master at all. It doesn't affect this project because the new one is technically a completely separate project, right? So forks are a different thing, but branches, those are changes that we're planning on reincorporating into the project in the near future. So let's pretend for a moment that we're Chris Walken, we're a developer, and we want to get in and make some changes. In fact, I've got a new branch office that's opening, and we're going to have a router that's deployed there. So this branch 3 is going to have a Cisco router. I need to get the configuration for that router written, and I need to get it deposited into this project. Okay, so I'm going with a network admin kind of example here because the internet is littered with people doing like just development projects, right? So we don't think about this in terms of a network admin or a sysadmin or whatever, but this does work that way too. So let me switch over to a window where I'm logged in as Chris. So here's Chris logged in, and he's looking at that same repository. I've invited him to my repository. He sees the same files. He's on that master branch. And so from here, he can see the project and he can clone it. You've got the option right here to get the URL for the project, and you can clone that down to have a copy of it. And see how it says use Git or check out with SVN, right? So it's telling you can use the regular Git tools, but you're connected up here to GitHub, or at least in my example you are. Now, Chris is a developer, and so when he does work, he's probably doing work from a command line like this, all right, not from a fancy GUI like I would as a project manager. And so what he's going to do is he is going to clone a project like the AITP demo. And the way you do that is just by saying git clone and then the URL of that project, and it brings it down. So I've gone ahead and done that already because he's been working on this. And when you clone it, you make a completely offline copy of that repository. So he now has a full copy of those configurations and the other data that's inside of them, right? So that's pretty cool, right? Now he can make whatever changes he wants. He can test them out. He can bring them up in containers, try it out on a router that he's got right there in the office, and it doesn't mess with the main project at all, right? So he can jump in here and start to change things. Now, before he does that, he needs to create a branch. That branch is what's going to encapsulate all the changes that he makes. So that's kind of the first step here. And when you create a branch, there might be one that already exists if he had started some work already. So I could do like git branch to see what branches exist. And so there's the master branch, and see how it's green, it's got a star. That's the one I'm connected to right now. There's config cleanup, branch 2. These are old branches that I had worked on before. Well, we're going to be adding a new router for a new branch office number 3. And so I'm going to create a new, I shouldn't use the term branch. It's going to get confusing because I got branch offices and I have branches in Git. So let's say that it's not a branch office. Let's say it's a DR site. We're going to be adding a DR site. So I'm going to create a new branch. I'll say Git. And you've got some choices. You can create the branch first and then connect to it. So I could say like Git branch and a name, and that's going to create the branch. Or I can create the branch and connect to it at the same time by saying Git checkout -b and then the name. So I might call this the DR configuration. Like that. That's going to be the name of my branch and I create it. So that would be one command that does it. But I'm going to do it as both commands just to separate it out and keep things clear. So first I'm going to create a branch. So I'll say git branch DR configuration. So this is going to be the configuration for our new DR site. Actually, I'm going to say DR config so I don't have to type so much. All right, so that's going to create that branch. And then I'm going to say git checkout DR-config. That's going to switch me from the master branch, which is not a branch, right? It's just the master, the origin. And it's going to switch me over to this new branch. If I do a git branch command, see how DR config is now lit up green? So every change I make now is going into that branch, not into the master. And from here, I can run a git status, and that's going to show me if I've made any changes. Looking at it right here, I see nothing to commit, working tree clean. I haven't changed anything. Well, let's change something. So if I look, I've got branch 2 router, branch 1 router. I bet the DR router is going to be pretty similar. So I'm just going to copy one of them. So I'll copy branch 1-rtr.txt to DR. We'll say DR site-rtr.txt. All right. So now I've got a new file in my directory. That's a change, right? So at a minimum, I've got a new change. Well, if I do git status, I see that it picked up the new file. It sees that dr site-rtr, but notice how it says it's a untracked file. It's not monitoring it for change. I need to tell Git to monitor that file. And I can do it one at a time, or I usually wait and do it all at the end, because you can say git add and then the specific file you're working on. Or if you're lazy like me, you just make all your changes, and when you're done, you do a git add -A, and then it just adds all the files and their changes. So that's what I usually do. So I'm going to leave that off for right now while I work on some of these files. All right. I'm going to modify that file a little bit. So I will nano that file. And so right now it's got a host name of branch 1. I'm going to change that to DR site. And then I would go through and change all the various other things that I do, right? The subnets and all that stuff. I'll do a quick replace of 172.18.1. And I'm going to change that to 172.254. Well, we'll keep it in the 18 range, 254, like that. So that's going to update all of those subnets and replace them throughout the config to get this kind of lined up with what I want that branch or that DR site to be. All right. So I'll go ahead and save that file and get that saved. All right. Now, just for my example here, I'm going to go and modify another file to be on the safe side. Maybe I need to have a special route added in on all the other branches to point to this one. So I might modify one of the other branches, like branch 2-rtr.txt. And let me find the routing section here. And I might add a new special route in here for the 172.18.254.0, 255.255.255.0 network, and I might be pointing that to some special different external IP or whatever. You know, maybe I've got an MPLS network, so I have a different endpoint for that one. I just need to add that DR route in there so it's got it. So I'm going to go ahead and punch that one in, and I'll save it. Now, personally, I would do this as two separate branches. One for bringing up the DR site, and another one for modifying the other branches to include a route to it. Wrapping it together like this, the more changes you have wrapped together, the bigger a chance is you're going to have one change interfere with another. So you might want to consider breaking it up a little more granularly, but I'm going to lump them together here just because I don't want to talk for 2 hours. So you know, we can go through and make any number of changes. I could even start modifying like the style sheet or the README file, right? I haven't messed with the README file in a while. It just says that it's a demo. So router configurations. So maybe I'm listing my router configurations, that there's branch 1, branch 2, and the DR site are now included. So I'm just adding that to the config, and I'll save that. All right, now when I do a git status, again, it sees all the changes that I'm making, but it's not actually tracking them yet. So I'm gonna go ahead and do a git add -A like that. And that's gonna tell it, I want it to track changes in all of the files, all right? And so now, and it was, if I paid attention here, it's actually telling me on the screen to do this stuff, right? But I'm just kind of cheating and doing it my own way. So now if I do a git status, the screen should look a bit different. Now I see readme.md has been modified, branch 2 router has been modified, DR site is an all new file, and they're green. They're being tracked. It knows those have changed, and if we want, we can commit those changes and submit them up for approval. All right, so that's what I'm going to do next. I'm going to go ahead and commit the change. So to commit the change, we need to make sure that we've got our name and our email address defined, and that's going to vary based on what Git client you're using. From the from the command line, you would say git config -- global user.email, and then you specify your email address, and then you would do user.name, and you would specify whatever your name was. And that way, when you submit a change, people know who submitted it, right? We got to be able to keep that straight. But if you're using an online service, you may need to provide this a different way. So you have to check your documentation on that. But next, I'm going to say git commit, and I want to commit the changes that I've made. But it's a good idea to leave a comment as far as what they are. So I'm going to do -m to specify a comment, and then I'll provide in quotes, I'm going to say added config for DR site and added, well, that's probably enough right there. I'll mention the routes in a moment when I do my pull request. So added config for DR site. Or we could even simplify that a little more and just say added DR site. Let's not get too wordy, and commit that one. All right. Now when I commit it, notice what it says. 3 files changed, 106 insertions. There were a lot of new lines, right? And then it's gone ahead and create mode 100644 DR site -rtr.txt. It's gone ahead and it's creating that file in the branch to get ready to be submitted up. So now I need to submit it up. And we do that by saying git push origin and then the name of our branch. Now I'm saying git push. I'm going to push my changes up to the origin where they came from. And at the origin, somebody's going to have to pull those changes into the actual project. That's why they call it a pull request. It's a weird term. You'll hear people call it a PR. It's a pull request. I don't like to use PR because a push request and a pull request would be the same thing, but anybody can push, so we don't really request that. So we're going to do a git push origin, and then I'm going to push it to master, right? Now I don't have permission to do that. I'm just I'm Chris Walken. I'm a regular user, right? But I'm going to go ahead and push it, and it's going to send that up, and I get that message. Everything is up to date. All right. Oh, actually, hang on. Sorry, I'm not connected to master. Let me git status again, or git branch. And there we go. So I'm connected to DR config. So actually what I should have done was a git push origin DR config. I pushed to the wrong place. So let me try it again. There we go. And I can see that it's pushed it along. It's got that delta, 3 of 3 objects changed. And now it's telling me I need to create a pull request. I need to go and submit the documentation to have somebody pull this in so that it'll be ready to go. All right. So as a user, Chris Walken is going to go to the GitHub page, and notice dr config had recent pushes less than a minute ago. I didn't even update this page. It was already updated and waited for me. And it's telling him, hey, compare and pull request, right? And so if he jumps over to the pull request tab, he'll see that same notice right there, and he has the ability to create a new pull request, all right? So if I do like compare and pull, it's offering to open up a pull request, and he can say what it is. It has added DR site, and now he can add a little more information. So, so you can say like I added a config file for the DR router. I also modified the existing routers to add a route to the DR site networks. Something like that. You can be very, very verbose right here. It can explain all sorts of information, a lot of the things that we would have in a normal change ticket. And then he can create that pull request. Now at that point, his work is done. He's not allowed to change the master branch. He's just able to submit this information, and that's it. Now it's up to me as the maintainer of this repository to go and do something about it. And I can see on my screen, so now I've switched over to the Don Pezet screen. So this is me. And I can see Chris Walken has a new router configuration. Actually, that's old, that's 2 hours ago. So I'm not seeing the update yet. I bet if I refresh my screen, I will. So let me refresh that. And I see a little note right here, pull requests 1. So there's 1 pull request waiting for me. If I jump in there, added DR site, opened 37 seconds ago by Chris Walken. And so if I click added DR site, I can take a look at it. Now, as the project manager here, I can evaluate this change. Am I ready for this change or not? If I click on commits, I can see the commit itself, what Chris submitted, and I can go to files changed, and I can see exactly what he did. What did he do? Well, he modified the README file. I see he added these lines. He modified branch 2 router. He added this line, it's green. And then he added a whole new file, drsite-rtr.txt, and I can see that all right here, all that information. Okay, so I now have a good vision exactly of what he did. If there are red lines, those are things he took away. If there's green lines, those are things he added, and I can review it. All right, is this good work? Is this okay? And if I decide it's not okay, well, that's where we have this conversation. So we click on the conversation tab, and now I can follow up and add more comments like, well, actually you're missing this, or can I suggest you change that, and so on. Or if I'm happy with it, oh, well, let's say I'm super unhappy with it, I can just close the pull request, throw it away, right? But if I'm happy with it, I can merge the pull request. Now, he only submitted 1. Sometimes people do more than 1 commit. Like, well, you guys saw me, I committed to the wrong branch first. So sometimes people commit multiple times to the same branch. And so you can do what's called squash and merge. So it puts them all together and applies them, or you can apply them individually. So you'll see different options here, what you want to do. I'm going to choose squash and merge. It's only 1 request, so it's not going to really do anything different. So I'll go ahead and approve that. And when I do that, I'm just going to confirm it. It's going to merge that in. And now when I go to my main code base, I'm going to switch back over. I'm looking at the master. There's that DR site file, and I can see they've got that number 4 beside them, letting me know what changed and what got them there. I've got a record of exactly what happened. And if something goes wrong, if branch 2 calls me the next day and says, we can't get on the internet, something's wrong, something broke, I can say, all right, well, let me go see what was the last thing to change on branch 2. Oh, we added the DR site. Huh, let me go take a look at that. And so we can bring up that. And now I can see here's exactly what changed on branch 2. And that speeds up troubleshooting so fast. If I know the problem appeared on Monday and I've got changes that happened on Sunday, pretty good chance I need to roll them back, right? And I didn't even have to come up with a rollback plan. If this replaced a line, I would see the old line in red. And so I could just copy and paste the red line and put it back. We're back in business, right? So it's a phenomenal tool for being able to track change and actually enforce some of the things we would normally expect in a change ticket, but doing it here in a far less painful manner, right? your developers, they're used to working from the command line anyway. All that stuff with the Git utility is things they regularly do. But as a project manager, I just have a nice little web page, and I can look at exactly what's changed and what's not. I can approve or deny, and I've got a full-blown record. Even though this has been approved, committed, and done, it's in here, and I still have that record. I can see that history, and that's really the purpose of products like this, like GitHub and GitLab and Git itself. Now, developers, they get pretty handy with this stuff because they have to keep track of what branch am I connected to, and maybe they're working on more than one branch, and so they've got to remember, like when they're done with one branch, they need to say git checkout and switch to another one. Like I'll switch over to master. The problem is they might have some local files that have changed that are different than the master, and so they might need to do a git pull origin master to make sure that all their files are up to date. And so see how mine resynced those new files down. And so now when I do a git status, I'm connected to the master and everything is clean and up to date. I now have a direct reflection of what's in the actual project and not something that's changed or modified. And that's useful too. If a programmer wants to experiment with something, they could try a change, and if it breaks everything, they just need to re-pull from the master and it'll reset everything back to the way it was, right? If I start messing around with the style sheet, so I'm gonna mess with that style sheet, and I go in and I don't know, I delete a line or something, you know, let me just mess with the file a little bit, maybe put some bad syntax in there, and I save it. And I'm like, oh shoot, I saved that file. I meant to throw away my changes. Well, we can always just retrieve that file again. You can say like git checkout styles.css, and see how it says updated one path from index. And if I do a git status, I have spelled status wrong every time during this presentation. See how it shows no changes? And if I take a look at that style CSS, everything's back, right? I can just reset that one file. Now it's back to nice and clean, or I can reset the whole thing if I want to really go crazy. I could say, I'll do a full, like a hard reset where it re-downloads files, even the ones that aren't changed. I could say git fetch origin, like that, and then git reset --hard origin / master. And that says throw away everything I have and just re-download it all, right? And so now it's gonna reset everything and I'm right back. I can do that git status, everything's happy, and we are still connected, still connected to master and ready to go. So that's basically a high-level overview of how we can use a product like Git to manage change in our environment. And programmers, they use this stuff every day. In fact, it's kind of become an expectation. If you're working on a web application or really any kind of dev project, you're probably using Git these days. Maybe not with GitHub, but with something. But in the world of like network engineers and sysadmins and stuff like that, at a minimum, you can use this to track your documentation. You can track config files. It's really cool when you're doing things like Terraform. Those are all super great ways that we can leverage this to basically perform change management right here with our developer tools. All right, so I have talked a lot, actually longer than I anticipated. What I want to do is I want to open up to a Q&A. So give everybody a chance to ask some questions. I'm going to stop my desktop share. And, you know, there's a few ways we can do this, but one of the easy things to do is if you have a question, actually, I was going to tell you you could raise your hand. Where's the raise your hand option? Or do I not see that? If you look at the participant list, you should have a raise your hand button that I'm not seeing. Where is that?
I don't know if Zoom has that or not.
Maybe not. I thought it did. Wes, do you know?
Yeah, you have to choose participants. And when you choose participants, select your name, and there's a raise hand icon at the bottom. So go to participants in Zoom.
Huh. Yeah, I don't see that. I see I can do a thumbs up and clap hands, but I don't see a raise hand. Weird.
Bottom left-hand side.
Yeah, it's all the way on the left-hand side.
It must be because I'm the host. I guess I can't raise my hand. All right, so So I got a couple raised hands. I guess we'll start with Michael.
Well, okay. You said that there is GitHub and GitLab and some other things that are available. If you didn't want to deal specifically with Microsoft or anyone else, would you be able to host that software locally so that you were running your own internal GitHub?
Absolutely. And it doesn't even take a lot of effort. Like if you have a shared folder, Git doesn't actually need any services or anything special to run. Like it just needs storage. If you poke around, I'm going to share my desktop again to give you kind of the under the hood view of it. Let's see. All right. So, all those commands I was issuing about branching and so on, when I would do a listing, you just see the project files. But if I do a deeper look, there's a subfolder called .git. And if you look in there, all of a sudden you'll start to see things like the branches and the logs and the other information. And so you can find, I haven't downloaded any of the branches right now because I'm checked out on master. But this is where that stuff ends up. And this is how it keeps those separate from the others. And so it doesn't need a server running to do it. It just needs shared storage. So at a bare minimum, you can leverage Git by itself with no internet connection whatsoever. But if you want to go a little more fancy, there are systems that you can run on-prem that let you do the whole pull request side of things too. There's a couple of software clients. One that pops to mind is Git Kraken. And with that one, it's kind of cool. Their logo is a kraken, the octopus thing. It's very witty, but that one actually has the whole feature set where you can create the repositories and stuff and do it entirely in your own environment without having to leverage third-party stuff at all. All right, any other questions?
Yes, Don.
Oh, go ahead, Stephen. Yes.
I'm wondering about, can you use Git to make changes on a website, and how would you approach that type of process?
Absolutely. A website, it could be written in JavaScript or PHP. It could be ASP. I guess some people still use that. So it could be one of the various web languages. But at the end of the day, websites are just text files, right? And like that style sheet that I modified there a moment ago, that would be part of a website or an HTML, PHP file. Let me see what I have in my repository. Do I have anything good, or is it just simple stuff? I think it's just simple stuff. Actually, that heartbeat file is kind of a fun one. Let me share my desktop again and bring this up. So there we go. All right, so looking at my little demo project here, I've got this heartbeat.php, and this is a heartbeat file. I use this on some of my Amazon web servers, virtual machine instances that I bring up in AWS. When you have a load balancer, you can use a health check to make sure that your servers are up and going. It's just a web page, and you can pull it. So if we look at that file, it's written in PHP, and so that's what I'm seeing right here, and it's generating HTML is what the PHP is doing, and it's interfacing with Amazon's API to render a lot of data. So that's basically the purpose of this file. But at the end of the day, it is just PHP and HTML. And so if I were to go in and start modifying that here, I could do that, and then I could run a local copy of Apache or a Docker container or whatever that had a web server that would serve this page up, so I could test my changes before I try and push that up into my actual production environment. So if I start to mess with this particular file, right? So here I'm editing it, and I can see all that information, and maybe I'll change the syntax down here. The header right now is ITProTV sample page. Maybe I change that to the heartbeat page. All right, and I save that. When I do a Git Status, it sees that change, and when I add that in to be tracked, it's going to see it as modified. I can do a Git Diff, and it'll show me the difference. Oops, I guess I have to do of that file. Why is Git Diff not showing me my differences? Normally, it would show me my differences. Oh, It's because I didn't branch. I'm stuck on the master right now. So it has to have something to compare against, and I'm messing with the master branch. So I should be in a branch, then it would show me the differences. But now I can work with it, and as far as web applications, they do great with this. In fact, they're easier to manage than some other things.
Very good.
Yeah. I guess the only real big difference would be you probably have image files that go along with it. And image files are a little trickier because you can't track what actually changed in the image file aside from if the file's been replaced. So that's not perfect, but they're binaries, and that's really all you can do.
What's the security like on the GitHub or GitCrack or whatever brand? Is it something that you can configure that you only let your local team of developers get into, or is it something that has to be public?
So GitHub has some of the best security policies in place of any company because the data they store is so sensitive, right? If I break into your Facebook account, what do I get? You know, your pictures, your birthday, you know, some basic information. But if I break into your GitHub account, now I can get some really, really good stuff that could compromise a number of business networks. So they have really stringent security policies in place. But when you create a repository in GitHub, you have a choice to make it a public repository or a private. And if you make it public, everyone in the world can see it. And everyone in the world can clone it to make their own copy. So it's really important that you choose to do a private repository if you don't want it to get out there. But even if you choose public, they have automated scripts that run that scan over repositories. They look for things like API keys and credentials and stuff, and they'll actually notice when you screw up and post like a security certificate. They'll catch that pretty fast, and so that's really nice. It's a second set of eyes. But they also have something called Dependabot, and what Dependabot does is it checks your projects for dependencies. And sometimes, you know, you might have a script that depends on some other library, and that library has a vulnerability in it. And so Dependabot will pick that up. It'll say, hey, you need to update this library. So it's really almost like free security auditing across an application. That doesn't work so well with like the Cisco router config I showed you earlier, but for a web application or something with dependencies, it's a really helpful thing.
Don, this is I guess, should I raise my hand?
Oh, it's all right. You can go.
There you go. I was wondering, the Linux world is command line, and I don't know if there is other products that actually, I mean, there are a lot of people that are not command line types. And I was wondering, I haven't actually seen any, but I haven't explored it either. But are there other products that use more of a file explorer type approach, or an approach where it's more point and click?
Yeah, absolutely. Let me share my screen. I'm going to show you two. Let me go ahead and bring this up. Okay, I'm going to start with something free. So there is a client. There's a number of GNOME clients that are out there, and one of them is called GitG. So GITG. All right. It's by the GNOME group, and it's completely free. And with GitG, it's a graphical user interface that basically lets you navigate through a repository. Okay. And so I'm bringing up a few different screens here, and see how this looks a lot like what I saw on the GitHub webpage. But this would work even without GitHub if you were just pointing it to a local repository on your own hard drive. And it gives you that GUI where you can see things without having to fuss around with a command line. You can navigate through the files, like here in the files view. I can actually see those files. Here's a tree like you'd see in the Windows Explorer. You can edit the files from in here. And this thing is 100% free, GitG. What GitG doesn't do is interface with GitHub. It's designed if you're just running your own local repositories and you want to manage it that way, and that's all it does. And it's really good at that, but that's all it does. But there's a number of paid clients out there that interface with GitHub. Actually, GitHub has their own desktop client too. I've not heard good things about it, so I've not run it myself. But I mentioned one a moment ago called Git Kraken, And let me bring that up. So it's GITKRAKEN. And they have a really slick looking, very modern graphical user interface that lets you keep track of your projects, the timelines, view the files, and then you can edit your files through your regular Windows Explorer or whatever you want. But this is a paid product. So, it says download for free. The free functionality is pretty limited, and almost all the good stuff, like the Git Kraken boards and timelines, they want you to pay. I think it's, how much is it? For the Pro Suite, so for the big one, it's $80 a year, which is not too bad. But an individual license starts at $30 a year. So it's not outrageously priced, but it's not free either. But it does give you that GUI, and it's regarded as one of the most powerful graphical user interfaces for it. So you don't have to be a command line warrior to use this stuff. There are tools that are out there.
For those of us who are command line warriors, is there a cheat sheet that you're familiar with or that you particularly like?
There's a couple of websites that are out there. I think I'm beholden to say, well, the training at ITProTV on Git is top notch. But there actually are a couple of websites that are out there. I'd have to dig through my bookmarks to find them, but there was one. Let me see if I can just Google it real quick. There was one that I came across a while back that was really nice because it was so simple, and the name actually said something like that. It was like Git without the BS. I'm trying to find it. I can't find it. Yeah, it was a nice little page. I'll have to dig that one up and see if I can find it to post later. But there's no shortage of cheat sheets that are out there. Simple. I don't remember if it. Oh. All right. So it's called the Git the Simple Guide. I just found it. So let me post this one. I like it. The title for the page is Git the Simple Guide, no deep shit. So it's designed to be kind of straightforward. And let me throw it in the chat. If you want to Google for it, the gentleman who made it, his name is Roger Dudler, ROGERDUDLER, Roger Dudler. And he's got it posted. It's actually in a GitHub repository that you can go and view. And it's basically got the 15 or 20 most commonly used commands and reference all laid out in just one of those vertical scrolling web pages. So really easy to use. All right, any other questions? See, a couple of hands are still up, but I think those are from the old questions, right? Let me bump those down. All right, well, I hope you guys enjoyed it. This was recorded, so I'm going to get it posted over onto YouTube probably tomorrow. If you think of questions later on, things that just didn't occur to you now, or if you're watching this recorded for the first time and you have a question, just throw them right there on YouTube, and I'll try and answer them. Again, I'm not a developer, so if you ask questions that are pertaining to that, what I'll do is I'll reach over to we have a developer, Justin, who's one of our trainers, and he knows this stuff inside and out. He probably would have been better at this presentation than I was, but I can always get him to help and answer questions, and make sure you get the information that you need. But hopefully, through this presentation, you got a chance to learn how we can use a solution like Git to enforce change control in our environment for anything that uses text-based configuration files.
Thanks, Don.
Thank you, Don. Well, if there are no further questions, we'll go ahead and sign off for the evening. I'm not sure of the date of the next meeting because the calendar is not updated. I can't remember if it's August or September.
Yeah, I know we had talked about skipping over August at one point. because of back to school, but of course back then we had no idea what life was going to be like right now. So, and also I'm still working, I'm trying to line up Anthony Sequeira to do the Cisco ACI presentation. So definitely stay tuned to see, you know, as soon as we get that solidified, we'll send out an email announcement, and it'll most likely, at this point, I think it'll probably still be another Zoom based meeting, but we'll see. Who knows what fortune will hold for us.
Absolutely true. We definitely have a meeting scheduled for September 22nd, and we may or may not put one in August. We'll please follow the website in order to find out. That website, if you didn't know, is AITP-NCFL.org. And with that, we wish you all a good evening. Thank you again, Don. Here is your gift card. And have a wonderful evening. Everybody stay safe out there, and we'll talk to you very soon.
Thank you, everybody.
All right.
Thank you.
Thanks, Don. Great presentation.